All right, howdy, AP Human Geography students. In this lecture, we're going to be talking about population pyramids. Very useful tools to study population. They're called age-sex composition graphs, but more commonly, population pyramid. The population pyramid is based on really only age and gender data, but can provide a lot of really important insights into a range of things like birth rates, death rates, life expectancy, economic development. Population pyramids can also hint at past events like wars or natural disasters, political changes or policies, epidemics, etc. When population pyramids first became popular in the 50s and before, most countries reflected a actual kind of pyramid shape that they're named for. For reasons we're going to be covering soon, many population pyramids, or the shapes of many countries' population pyramids, no longer really reflect a pyramid. You can see that in the age-sex graph for the United States pictured here. It doesn't much resemble a pyramid at all, does it? Except maybe at the very top. In terms of how you read this, the population pyramid is sort of split down the middle, generally with males on the left, females on the right. That's the sex part, showing male and female ratios. The ages are shown from the bottom to the top in age cohorts, as they're called, of about 5 years, right? So 0 to 4, 5 to 9, 10 to 14, 15 to 19, all the way up. This population pyramid shows each cohort as a percentage of the total population. Sometimes, though, and you have to pay attention to this when you're looking at them, it might show them as an absolute number, right? Talking about however many millions or hundreds of thousands are in that particular age category. And so this population pyramid shows the United States, but population pyramids can be constructed really at all scales, for cities or states, for regions like Western Europe, or continents like Africa, or even the world. All right, and hopefully you got to notice some of the differences between each of those pyramids. Those differences are kind of what we're going to be exploring and explaining in the rest of this lecture here. This is the population pyramid for Nigeria, the most populous country in Africa and one of the fastest growing as well. We can see the fast growth in the wide base of this pyramid, which then sort of tapers or narrows at the top. Notice the longest bars are the bottom three. They show children age 0 to 14. As those kids age, the middle age categories of this population pyramid will sort of grow as well as it's filled up by this larger group of people that are right now still very young. There's also probably going to be a lot more children born from those kids when they reach their childbearing years. And if those families are having more than, 2.1 kids each, the bottom bars of the new generation will be even longer than their parents' generation was. And as you look, the bars sort of narrow. They taper at the top, right? As you look towards these older age cohorts, and that is reflecting life expectancy, the smaller surviving groups of children maybe from previous decades when the infant mortality rate might have been much higher, or just the natural kind of die-off of the elderly in places where medical care is more scarce and people are more likely to die of a variety of other causes, as you learned about in studying the epidemiological transition model. One of the clearest and maybe primary effects of war is the killing of people. Often half or more deaths in wartime are civilians across all ages, but the loss of fighting age people, usually considered males between 18 and 40 years of age, is often much more pronounced and can be seen pretty easily on a population pyramid. This is for a few reasons, right? Birth rates often slow down in what is known as a birth deficit during wartime because men and women are often separated during the period of the war. And even if they aren't, a lot of people decide to maybe put off having children until the war is over. This pyramid shows Russia, who, as the Soviet Union during World War II, lost 20 million people in that conflict, at least. I picked a pyramid from 1994, from a couple decades back, because it's a little bit easier to see the closer you get to the Second World War. It would be very obvious if we pulled up a pyramid from, 1950 or something right after the war. But even so, you can still sort of see it here. Notice the sharp drop in population for men aged 54 to 89 or so, right? When you compare them to women of the same age. World War II had similar effects on Germany and several other countries that had very high death tolls. Generally, what you want to see, though, is a pyramid that looks mostly symmetrical, kind of like the one for Nigeria on the previous slide, if you want to go back and look, where one side looks a lot like the other. Even in the oldest age cohorts, you might just kind of see that there's slightly more women than men, which reflects the fact that women just kind of naturally tend to live a little bit longer than men for, well, maybe not naturally. There might be a variety of reasons that explain that, but typically you want to see that kind of gradual change from one cohort to the next, and assuming that there hasn't been anything like a war or natural disaster or plague, most pyramids will show that. And when you see these very sudden changes, it can be a hint that there's been some kind of government policy or war or conflict that has altered birth rates. Okay, boomer. All right. A spike in a birth rate is known as a baby boom. This is where we get the term baby boomers, right? Such as after World War II in the United States. It also happens in strong economic times when people feel comfortable having several children. Our baby boom, the U.S. baby boom, lasted from about 1946, right after the end of World War II, until as long as 1965, right? Anybody sort of born within that time period is considered one of these baby boomers. You can see that on the population pyramid of the United States here above, right? If you look sort of right at the center, you see that baby boomer generation who's born from the people that had fought in World War II. Or who are the people that fought in World War II. And the dip you see right after them, the baby busters, reflects what is called a baby bust, when fewer babies are sort of born as that boom passes, right? As whatever emotions or feelings or reconnection or economic conditions encouraged people to have these larger families, that drops off after a while, and that is called a baby bust. Once the boomers reach childbearing age, there is another boom of births. And because it's the product of an earlier boom, this is called an echo boom and reflects the larger cohort of baby boomers giving birth to this larger cohort of the children of baby boomers. Population pyramid data can often be used to estimate other things, like the dependency ratio. This is one of our vocab words, and it refers to a value that compares the working to the non-working parts of a population, basically, all right? Demographers consider people between the ages of 15 to 64 the potential workforce, I'm using air quotes there, of a country, whether or not those people are actually employed or not. All the rest, the people under the age of 15, the people over the age of 64, are, again, in air quotes, the dependent population, and are considered too young or too old to work, and thus must be cared for and paid for. The dependency ratio is kind of a simple calculation. You can figure it out by dividing the dependent workforce by the potential workforce. So if we do this for the United States, something like 34.1% of the USA is too old or too young to work. 65.9% of the USA is in that sort of potential workforce category. You do the math, you should get a number around 0.52. That means for every one worker in the United States, they are supporting about half of another person, right? When this is flipped, when you have a lot of people maybe in the young and old age categories, you might get something like a 1-to-1, right? Where for every person working, they're supporting a non-working person, which means the wealth of your country isn't going to go as far, right? It's supporting this large dependent group of people. Some of the last stuff we'll look here is that population pyramids and the demographic transition model can generally be applied together, and certain shapes of population pyramids should be associated with specific stages of the DTM. And we want to talk about how we can kind of identify some of those shapes on the next couple slides. And I encourage you to go back and watch this part of the lecture a couple times until you feel pretty confident in what each one might look like. This is supposedly a population pyramid for stage 1, where you see a very wide base reflecting a really high birth rate that narrows very quickly, right? Starts to drop off really quickly, showing a high death rate with very few people in the older age cohorts. Now, this shows the population for Kinshasa, Congo, all right? Congo in particular. What you should keep in mind is we really want to associate this with stage 2. There are no stage 1 countries. Remember that, right? There's no countries in stage 1. There may be certain groups, certain regions of countries, especially maybe in sub-Saharan Africa, places in maybe in South Asia or in Central Asia, where people are still living kind of older style lives, right? Maybe hunting and gathering, maybe living as sort of like subsistence farmers in parts of India or things like that. Those small kind of village level populations, they might maybe reflect stage 1, but there are no countries today that reflect stage 1. Stage 2, however, right, is what you should associate most graphs that look like that with. This is a good example of stage 2, the Philippines in 2016, where you see this wide base shows that high birth rate, this wider and taller sort of pyramid that doesn't narrow quite so quickly, showing people living a little bit longer, but it still does narrow and looks like a pyramid, which is how a lot of countries looked not that long ago when this style of graph first became popular. And then, of course, it narrows at the top and is showing the low life expectancy that remains even in stage 2. Stage 3 starts to take on this kind of domed shape where you have more people that are living to be older, right? And so the middle categories are kind of filling out a little bit. And you have proportionally fewer births where you start to see the age categories in the bottom 3 or 4 age cohorts about the same, right? Maybe they'll grow here or there or be slightly bigger as you move down, but generally they're starting to approach zero population growth, right? They're starting to look like population's not really growing at all. It's sort of staying the same. Now remember, if you remember talking about population momentum, the population of this country is still going to continue to grow as this pyramid sort of fills up a little bit, right? As some of the older categories fill up and these smaller age cohorts continue to be born at the bottom, you'll still see some growth in the meantime. Population pyramid for stage 4 looks very narrow near the top and bottom, is wide in the middle, and this shows birth rates kind of way lower in the current generation than in previous generations. And the die-off of the elderly sort of seen at the top. Even though a stage 4 pyramid, as you can see here, will generally have a much fuller top than, say, a stage 3 or stage 2 pyramid. This one shows Australia, which is a very developed country that's also approached, zero population growth and is no longer in these rapidly growing stages of 2 or 3. And then this would be a population pyramid for stage 5. Japan is our example for stage 5 because Japan's population peaked at about 127 million. And by mid-century, maybe by 2050 or so, it's likely to be around 100 million. So nearly losing something like 20% of its current population. In addition, Japan discourages immigration, and so its population is declining rapidly. And you can see that in the very small base, the larger top, and how the age cohorts as you approach the bottom are getting smaller and smaller as the average family size is reducing, but also as smaller and smaller cohorts of people are giving birth to smaller cohorts themselves, right? 100 people that give birth to 90 people. Well, when those 90 people grow up and they give birth to, 2 or fewer kids each, well, it's going to be even smaller, right? It's going to be 80 kids or something born and so on. And that size is going to keep getting smaller and smaller until Japan figures out a way to reverse that, if they do, right? This is kind of ends up looking sort of like an inverted pyramid, an upside down Christmas tree, or something like that. This is an interesting graph that shows the population pyramid of the world, all right, at different stages. If you take a minute to sort of study it, you can see the dark blue in the middle has that almost kind of pyramid shape for the world, this very narrow, spiky pyramid of 1950s. And as the development of the world overall starts to grow, as medical technology diffuses through the medical revolution, things like vaccines become more widely available, and countries progress through the stages of the epidemiological transition model, we will see our birth rates maybe shrink and those edges start to straighten out. But overall, population is going to grow and sort of widen out in the older age categories globally, so that by 2100 or so, by the end of the century, we'll have a much different looking population pyramid than the one you see for 2018 perhaps. So here it is again, where you can see the demographic transition model and its various examples and birth rates and death rates, natural increase rate changes, and so on, with good example countries that correspond to that stage of the demographic transition listed below. Just remember, South Sudan comes close to a stage 1 country, but technically demographers say there are no stage 1 countries today. So depending on if you're in a stage 2 or stage 5 country experiencing rapid growth in stage 2 or slow or maybe even negative growth in stage 5, it's going to have different effects on your country that we should examine a little bit. The effects of rapid growth might include a greater need of services for children, right? Things like more schools or daycares to take care of this large dependent population. One of the, I don't know if maybe advantages, but that there's going to be a lot fewer old people, and that means there's a lot less money that needs to be spent on them for old folks home, for medical care, things like that, where in our country, for example, it's typically people at the later stages of life that are, that are consuming a lot of kind of medical care and medical costs, and so on. One of the other things happening in a rapidly growing country is typically people are moving to cities to find work, right? Countries with the fastest growth rates tend to also have the fastest growing cities as people are seeking opportunities in those urban centers. Because of that, you will also often see these kind of quickly constructed buildings to house workers, right? Entire neighborhoods or areas that lack vital services or infrastructure, whether it be water or electricity or sanitation, and end up becoming sort of slums or favelas or barrios, Bidenvilles, depending on where you live, what they call them different things. But that kind of quickly constructed housing to to house these rapidly growing populations is another side effect. You'll also see some migration to more developed countries. This can be a kind of safety valve for these rapidly growing places where people will migrate out of a country like, say, Nigeria and move to slower growing countries like Europe or the United States. And those immigrant populations can be part of what helps your very slow growing country continue to see some population growth, right? Through this influx of new people and maybe them having more kids than the average person does in your stage 4 or 5 country. Now, the effects of slow growth are the opposite in a lot of ways, right? Instead of lots of services for children, slow growth countries, stage 3, stage 4, 5, tend to need services for the elderly. So larger retirement programs like Social Security or some form of that. Medical programs like Medicare or, expanded insurance programs. On the flip side of this, because there's fewer young people, there's less money that needs to be spent on them for scholarships or daycare or even healthcare for young kids. And that's money that can be reinvested in other places, right? A problem is that you could have a shortage of workers in the future, that your economy has, sort of X amount of jobs in it today, but if your population shrinks, who's going to fill those jobs in the future, right? That might mean a loss of kind of economic power for your country overall as it's harder and harder to find workers and keep your economy at the size that it was. Migrants moving into a country, often to work low-wage jobs or so, can be one way to sort of supplement that, right? And help resist that shrinkage in your economy. Which, sort of ties back as a good example of what we're talking about when we look at dependency ratio, where countries that have a lot of elderly people and maybe declining populations of very young people might require or, really need some kind of influx of immigrant labor in order to deal with that dependency ratio, right? Make sure there's enough money in the coffers in order for Social Security to be funded or for Medicaid or something like that to keep existing. There can also be political impacts, right? The voting patterns of a country might change as its population ages, right? Older people tend to generally be more conservative politically, right? And you might see that sort of grain of the vote, as it's called sometimes, as populations age, right? And the political parties starting to reflect that, and some of the policies of the country kind of becoming more conservative in line with its population. The last thing we can kind of look at here are some of the outside influences that you can see on a population pyramid. One we've mentioned before, one we haven't here is migration, right? Like, which I brought up on the last slide, but which you can see here in the UAE. The United Arab Emirates allows a lot of immigrants from places like South Asia, from Bangladesh, and other sort of impoverished parts of the world to move to the UAE temporarily as guest workers, right? To work on the oil fields there or in construction projects, to work in the hotels and various resorts that you could find there. And because of that, you see this really skewed age-sex graph, right? Where there are all these extra men between the ages of, 25 and 50 or so that are there as guest workers, right? And you don't quite see that symmetry on the other side at all, right? That's a big hint that something unusual or different is going on. In this case, for the UAE, it reflects this very large guest worker population. The other thing is, famine or war, right? Or disease or the variety of other things we mentioned, sort of like with Russia, where again, this is Russia in 2014. If you look kind of at the ages, 60 to 90 or so, you can see, again, the effects of World War II there with this much smaller group of men across the way. So hopefully that helps you out a little bit and helps you read population pyramids a little bit more than the quick video you watched before this, and understand some of the things you can tell about them, about a country through their population pyramid, and some of the effects that various amounts of growth or decline might have on your population as well. Thanks a lot, guys, and talk to you again real soon.